De Moivre's theorem is like this one: cos theta plus I sin theta whole to the power n equals cos n theta plus I sin n theta. Okay. Also, we must know that if cos theta plus I sin theta can be expressed as e to the power I theta. Okay, these are two statements we must have in order to solve the problems which relate trigonometry with the complex number. So, okay, here how can we prove the equation first? For proving equation first, what can we do? Like do this thing: cos theta 1 plus I sin theta 1 multiply cos theta 2 plus I sin theta 2. Okay, and if we let us open the brackets and multiply the two complex numbers. Cos theta 1 into cos theta 2, this is like cos theta 1 cos theta 2 plus I sin theta 1 cos theta 2 plus I sin, okay, I cos theta 1 sin theta 2. And when I sin theta 1 and I sin theta 2 is multiplied, there will be I square sin theta 1 sin theta 2. So we can write I square as minus 1. So it will be sin theta 1 sin theta 2 with minus sign, right? Okay, if we collect all the real parts like this one and this one and the imaginary parts together, what we get? See, cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. This is the real part, and the imaginary part, taking iota outside, what we can write: sin theta 1 cos theta 2 sin theta 1 cos theta 2 plus cos theta 1 sin theta 2, right? So from trigonometric function cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, this is like cos theta 1 plus theta 2, you know that. And this will be like sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. It is sin theta 1 plus theta 2. Okay, so what did we find? We found that cos theta 1 plus I sin theta 1, this one and this one, when multiplied, the angles were added up. Okay, so okay, now if I had theta 1 equals theta 2, what will we get? It will be like cos theta plus I sin theta, and theta 1 equals theta 2. That's why the given problem would be like cos theta plus I sin theta into cos theta plus I sin theta, and we can write this way. Okay, and when in the result I will be doing theta 1 equals theta 2, that is equal to theta, it will be like cos 2 theta plus I sin 2 theta. Okay, like I am writing 2 theta as theta 1 plus theta 2. Okay, can be, because theta 1 and theta 2 are equal, and that is equal to sin theta. So in similar fashion, if I go on increasing the power of this very thing, cos theta plus I sin theta whole to the power n, it will be like adding up the theta 1 theta 2 theta 3 all will be added up, and it will be like cos n theta plus I sin n theta. And what does it, from where does it come? This is the statement of de Moivre's theorem. Okay, fine. You must know, like, what is cos theta? As as in finite series, we can write cos theta as 1. Yes, the series of cos theta can be cos theta is equal to minus theta square by factorial 2 plus theta to the power factorial 4 by factorial 4 minus theta to the power 6 by factorial 6 and so on. Okay, here all the powers of theta are even, right? And what about sine theta? Okay, sine theta is like theta minus theta cube by factorial 3 plus theta to the power factorial 5 by factorial 5. Okay, theta to the power 5 by factorial 5 minus theta to the power 7 by factorial 7 and so on. Okay, see what we can find if I do that. Cos theta plus I sine theta means I am taking this very equation and adding to this very equation after multiplying this second equation by I. So what am I going to get? 1 minus theta square by factorial 2 plus theta to the power factorial 4 by factorial 4 minus theta to the power 6 by factorial 6 plus dot dot and iota. This one is theta minus theta cube by factorial 3 plus theta to the power factorial to the power 5 by factorial 5 minus theta to the power 7 by factorial 7 plus dot dot dot. Okay, so what does it become? Let us see. Okay, 1 plus and opening the brackets of two brackets, what I am going to get 1 plus I theta. Okay, this one I theta, this one, and then minus theta squared by factorial 2 minus I theta cube by factorial 3 plus theta to the power factor 4 by factorial 4. Okay, and I theta to the power 5 by factorial 5 and similar fashion. So what can I say about this very thing? Okay, 1 plus I theta, this is plus I theta whole square by factorial 2 plus I theta whole cube by factorial 3 plus I theta whole to the power 4 by factorial 4 and I theta whole to the power 5 by factorial 5 and so on, right? And what is this? This is the series of exponential series, right? This is the exponential series where e to the power I theta is present. Okay, because since e to the power x equals 1 plus x squared by factorial 2 plus x cubed by factorial 3 plus dot dot dot. Yeah, I can also add another thing up to infinity. Okay, by this very series, this very thing, I can say that here, if in this series, if I put in place of x I theta, I will be getting this very series. Okay, the previous one series, this series. Okay, so what did I found? I found cos theta plus I sin theta can be written in the form e to the power I theta. Okay, okay, and if I multiply anything by that, like r cos theta plus I sin theta, then r e to the power I theta it will be. And if I can uh, raise this both side by power, say n, what I am going to find, that will be r e to the power I theta whole to the power n. It will be like r to the power n into e to the power I theta whole to the power n, and that can finally be written as r to the power n into e to the power I n theta, right? So this is the beauty of De Moivre's theorem that made this very thing r into cos theta plus I sin theta whole to the power n as r to the power n e to the power I n theta. Okay, so we can use this very thing